Hello, welcome everyone. This is Michael Newart, and this is the live Q&A for the eCourse EMF Solutions for Your Health. It is April 16th, 2019, and I have a lot of material to cover today. Thank you everybody for have at least 30 questions in here. So a lot of questions. I really appreciate that. And I'll be going through this fairly fast. And if you're on the line, we'll be allowing the people on the line to ask other questions as well. And feel free to interrupt if there's something that's not working, or if you need, or something's not clear. And I'm going to start with some questions here from um, Wojciech. And when the questions are, our body totally interacts with electric fields, thus making it impossible to take dependable measurements while holding a typical meter with an internal sensor antenna. So that's something from the eCourse. Um, on another website, they found a power frequency protection for you and your family that matches our electric field measurements with the PF5 meter is calibrated to measure electric fields relative to the person holding the meter. That way you get the correct reading. So the PF5 is a particular meter that's put out by EM Fields. They're the people that make the Acousti-Com and the Acoustimeter. And it's a magnetic field meter and electric field meter. So, Wojciech, what I'd say here, I would stick with what I'm saying, that when you hold a meter that has a little electric field antenna in it, your body affects it. And the people here who say that it's calibrated to measure the fields relative to the person holding the meter, you can try to do that, and you can basically recalibrate the meter to take account for your body, but your body can act as a shield and lower it, or it can act as an antenna and make it higher. So there's actually no easy, there's no good way to get an accurate calibration for that, because your body position is changing with respect to the source. So I would take issue with the people who would say that they can calibrate a point sensor type electric field meter to take account of the body, because there's too many variables there. In the right situation, you could, but you're going to have another situation that would be the wrong calibration. So I'd recommend that you have to stick with the body voltage testing if you want to get an accurate measurement, um, and not have the body interfere with the measurement. Also, I have a PF5 meter. Does this point measurement with the use of an extension stick more reliable? Does the stick have to have a minimum length itself? If so, what is it? What kind of material should a stick be made of for it to be the most efficient? So yes, when I have any kind of electric field sensor, not a body voltage meter, but just the sensors in the meter, whether that's even like a tri-field meter on the electric setting, the Alpha Labs, their AC electric meter, this EM Fields PF5 meter, if you have it on a stick away from your body, you're getting your body more out of the picture. And there's no, the more the better. So I figure usually 2 or 3 feet is pretty good. And you'd want to use something that's not conductive, like wood or plastic. If it's metal, it would conduct some of the field from your body to the meter. So you'd want to use wood or plastic, and probably 2 feet long is enough. 3 is even better. And what kind of meter is shown on page 162 of the PDF version of electric fields? Okay, I think I brought that up here. Let's see if I can find that. So we have, I believe this is the slide. And so this slide shows two pictures. So on the left here, this is a body voltage meter that at the EMF Center that we actually make for people. This is what we sell. We just take a very simple Gardner bender. I think it's model 3200. And we actually simplified. We don't have this piece here anymore. But we basically, it's just a long round wire going to a screwdriver in the ground. It's very simple. And that's just what we sell and rent to people if they don't want to make it themselves. On the right here, this meter here, that is a Bell, probably a 4180, 4190. It's a particular um, um, Bell company meter. It's not my favorite. I was using it in that particular test. I use another Bell, the 4080, an older version, which I think is much better. But that's basically a Gauss meter here. So here I'm testing a bed with a Gauss meter, and the meter on the left is a body voltage meter. So actually use a body voltage meter to measure electric fields. This is really the wrong picture for this purpose of how to measure electric fields. I think what we're trying to show here is you'd want to take a body voltage measurement on somebody's bed, but this is the wrong meter for that. I can see that confusion. Very good. The person holding me. So thank you, Wojciech. Let's go on to some questions here. Mary Ann. And actually, Mary Ann, I think maybe you're just getting on. I'm going to maybe go on to another question in case you're just getting set up. And then you can hear it live. Woman, Nejla has some questions. One is, I have a problem standing without moving my hands while holding the Gauss meter. I have other Gauss meters than the one recommended. It's a 3-axis, tri-axis, it's a 10 Mars TM192. So two things in there. A lot of the Gauss, the more sensitive the Gauss meter, the more sensitive it will be to a little shaking or a little movement. You might often see a Gauss meter, when you move it a little bit, you get a higher number for a moment, then it goes down. That's because we have the strong Earth's DC magnetic field, and when you move the meter, it's like the field is changing, just like these AC ELF fields. So it fools the meter into thinking there's an AC field, so you have to hold it still. And I've seen people that kind of have like a little shake, and they actually have to put it down to take a measurement. So sometimes you have to do something to stabilize it. Some people even take something like a heavy book and put it on that so that it doesn't quite shake as much in their hand. And then the 10 Mars TM192, haven't tested that particular Gauss meter, but in general, the 10 Mars meters are a little too cheap. I've carried them in the past, and I've had a lot of troubles with the RF versions of the 10 Mars, the TM195, the TM196, and we just couldn't carry it because there were just too many quality issues. So I would caution you from using a 10 Mars meter because of the quality troubles that they can have. Najla also has, at times, this gets interesting. This is all meter questions. We'll see what we can get to. This might be beyond the course. I get a peak value with the load on my HF38B. So that's a gigahertz solutions meter, HF38B. But when I attach the attenuator DG20, the peak value changes and the sound changes. Yes. So with that, the gigahertz solution meters are probably the most accurate meters out there for doing testing, but they're also sort of the most troublesome and the least easy to use. So what Najla is talking about here is the this particular meter, it tops out. You go to a certain number, and you've gotten to the max it will read. The same thing that happens, we have the HFE 35C, I have the HFE 59B. They all top out relatively quickly at relatively low levels. And so there's this attenuator you put in. You screw in another thing between the antenna and the body, and it basically allows you to it attenuates it. It brings down the strength of the field, the signal that the meter gets. So when you use that attenuator, it basically tells the meter 1/100th of the level that you really have. So it's like it allows you to basically read 100 times stronger because this attenuator is taking the signal down. But then when you look at the meter, you actually have to multiply the number on the meter by a factor of 100. So, because once you put that attenuator in there, it's actually reading 100 times too low, and so you have to manually times the number that you get on the meter by 100. And that's probably what you're seeing. So the same thing would happen with the sound feature. The sound feature would be a factor of 100 less also when you put in that attenuator. I have grounded wiring. I have no grounded wiring in the house. I am doing grounding, digging into the ground. The soil is not rocky. It's dry. What do you recommend in terms of installing ground rods, more than one ground rod? If so, how far apart should they be? What size that wire should be coming out to the canopy or to the electrical outlet? Can I attach more than one wire out of the rod? What size the rod should be? So to cover the grounding. So with grounding, if you have no grounding, it depends what you're grounding. So if you're grounding an electrical outlet, let's say you're going to plug in something, you need to have a good grounding for that. You need an electrician to bring in the proper grounding. If you are only grounding like some shielding material, like you're just all you want is to ground a canopy or some shielding at a bed, then you don't need the same kind of grounding you do for the electrical system. You could just have any ground rod. And what I usually do here in the United States is I usually get a half-inch diameter copper water pipe, 4 feet long. Just go to a hardware store, and I get then I get a grounding clamp for that at the hardware store. It clamps to the top of the rod. I pound the rod in, basically 3.5 feet into the ground. That's usually enough in most places, even if it's relatively dry. We're doing something like grounding a canopy. And then I run a wire from that ground clamp to my shield material. So it's pretty simple. Basically, any kind of rod that goes into the earth that's metal will work in any way you attach the wire. I just use the copper water pipe because it's an easy thing to get at hardware stores here. And it helps. The more wet the soil is and the deeper you go, the better. But if all you're doing is grounding a canopy or a shield, you do not need very intense.
Thank you, Satya.
You're very welcome. And then you should have the for computer. If for any reason the audio doesn't work well, hit what I meant is phone or computer. If you click on the phone, it immediately gives you the phone number to call and the access.
Okay, there we go. Yes, so if you're making a shield, if you're grounding a shield of some sort or a canopy, it's very tolerant how you ground it. Just almost anything to the earth. Like when we do body voltage measurements, we're often using a screwdriver that's just like a foot long into the earth. And so pretty much anything there, you just want to get to some earth. The deeper the better, the wetter the better. I live in an area 200 meters from a Wi-Fi telecom tower. RF at the outside at peak value is 1 all around. Let's see, 1. We don't have numbers here of what units we're talking about. I have inside some places 1, other varies. The house is 1 floor, ground floor. I'm working on shielding the large glass window walls. Do you recommend curtains or glass shielding? Okay. Yeah, first of all, we have to be careful if we're ever saying, I have a measurement level, you have to say what units it is in. Otherwise, we could make big mistakes. One of one thing could be 1,000 of another thing. So I probably can't give you an answer on that strength. But generally, when you're trying to shield a window, you can do glass shielding where you just put like a film on the glass, shielding film. And that works fairly good. The problem is it only shields the glass, and you still have often a little leakage around the frame, basically between the shielded glass and the wall or whatever you have. So I get better results if I do some kind of curtain kind of shield that covers the window. And I usually think of going at least 6 inches beyond the window, those 2 sides, the top and the bottom, overlapping the wall, so I get much better coverage. So that's what I'd recommend, although you can get a lot of shielding out of the glass. And then Najla is asking, is there a wiring error in these pictures? The red and the blue are hot. So I think this is in the Middle East, and I don't know the wiring system. But when we look at wires just in a box, we don't really know if they're wired correctly or not. That's actually fairly complicated. One clue that you can have, if you're wondering, is there a wiring error here or an issue, keep in mind that for normal modern wiring, where here in the United States we're using Romex or MC cable, some kind of cable where all the wires are in one assembly. In that case, when you have that kind of wiring, you'll typically, with your Gauss meter, you'll get a couple milligauss near the junction boxes, the switch boxes, the outlet boxes, and if you follow it along the wall, you might get a couple milligauss at the wall. But generally, when you get out about a foot from the wiring, it's almost gone, or a foot from the wall. So if you have a strong field, even like 30 milligauss, right on the wall where the switch box is, say, but you come off a foot away and it's already down like the 0.5, that's probably not a wiring error. That's just a typical field from the wiring. But if you're, say, 2 feet away and you still have a field related to that wiring, that typically is going to be one of two things. Either a wiring error where something is connected wrong, and that's a relatively complex thing for an electrician to figure out, but I do that. I've done that hundreds of times, maybe thousands of times now. And the other thing is, if you have an old wiring system, here in the United States, we call it knob and tube. In other parts of the world, there's different ways they've done this. But if you have the hot and the neutral wires separated, not in one cable like our Romex here, but if they're separated, like say like our knob and tube, you might have the neutral wire in one place and a foot over is the hot wire. That separation makes a high field. It's not a wiring error. You can easily get like 2 or 3 milligauss in the center of the room from that kind of wiring style, that old wiring style. It's not a wiring error. It's inherent in that kind of wiring style. So can't probably answer too much more without knowing more details about that. Thank you, Najla, for your questions. And let's see, let's go on to Marianne. And I hope everybody, this is the volume and everything is working out for you all right. I come from Denmark in Europe and would like to be able to clean houses over there as well as here in California. Are there different things to be aware of over there that you know about? Dirty electricity problem. The dirty electricity meters, you'd have to call them, but pretty much they're designed for the voltage of the system. So the ones in the U.S. would probably not work, even with an adapter, for the ones in Europe. But I have to check with you'd have to check with the manufacturer on that. As far as differences, all electrical systems have issues, and there are slight differences. I could never say one country versus another. Just being all over the United States and so many different states over time, there are differences in different areas. Different power companies use different schemes for their power lines and different kinds of transformer formats. And some places they don't have enough. Like in Wisconsin, where I grew up, a couple of years ago when I went back and I tested, several family members and all around that east part of the state, and I was surprised how the same problems were coming up in all these places that I hadn't seen in California, but in that part of Wisconsin, utilities had not put in adequate neutral wires to their transformers and things. So there were almost every house I went to was having stray current going through their water pipes into their grounding to the earth and out. So things can happen that I couldn't predict for different countries. Another good question, I want to start an EMF service, but I can't afford all the professional meters. I would like to make sure that I can do a decent job to go to people's houses. This is a really good question because a lot of people are doing this. What level of meters do you go to? Even Satya and I, do we invest in a $10,000 meter? Do we get by? What do we use? So I'm looking you have the Alpha UHS2 Gauss meter. So to me, that's fine for magnetic fields. That's great. You have the Acoustimeter AM10. That is kind of a beginning level meter that I think is good enough for someone who's going out and testing. I'd want to maybe add another RF meter to that if I could. That does a few other things, but actually that's a good starting meter. I'd be concerned about going to a cheaper meter like an Acousticom and going to a house doing any professional testing, but the Acoustimeter is pretty good. A body volt meter is great. The tri-field meter, the TF2, that is a little bit, a kind of, I wouldn't use it for testing purposes. It helps to flush out things, but I wouldn't use its numbers. Dirty electricity meter with a few filters, yeah, that's fine. And a clamp on ammeter, yeah. You actually have a very good starting kit here to do that. To me, what this is, Alpha UHS meter, Acoustimeter, AM10, body volt meter is the basics. That's about the minimum. And then after that, you're basically usually looking for better RF meters, some of the gigahertz solution meters. If you want to spend more, but what would you have there? You have enough to definitely start some testing. You mentioned the option of shielding a biomat for electric fields. I measured a biomat that had electric fields of 4 volts. That's probably body voltage, I assume. How could I shield it? If I shield it, won't the person using it necessarily be grounding? in which case it would be crucial to know that the electric fields in the surrounding our environment is very low. Yeah. So we won't, get into this much, but when you're something like the biomat, my understanding is they're making a magnetic field that is hopefully those frequencies are healthful, and but as a result, there's wires in there, there's electric fields, so you can shield it. You do some kind of shielding fabric typically on top of it, and you'd ground it. But definitely, you would not want to put your body directly onto that electric shield material, because now you'd be grounding yourself, earthing yourself, and that would be to me, the wrong thing to do. You'd have to put something insulating up top of that, like a good cotton blanket, or a couple thick cotton sheets, something that would insulate you electrically from that shield material. And I think of that too, and there's other cases like that where you're doing shielding. We had a case where Satya found some really good results if you could shield right on top of the mattress, right under the sheets. We had to make sure that there was enough insulating pad between that grounded electric field shield sheet on top of the mattress and where the person was in that sheet, that the bed sheet. There had to be enough insulation there so that the person wouldn't actually be electrically connected to that grounding material. I also have to be careful. The closer you are to the material, you want to be careful that you're not grounding yourself somehow. And I understand that it's a good idea to earth yourself in an environment. It's not a good idea to earth yourself in an environment with high electric fields. I agree. Why is it a problem to earth if the radio frequency field is larger than 0.001 microwatt per centimeter squared? Do we absorb more RFs if we are grounded? Does that mean that walking barefoot on the beach next to someone carrying a cell phone is actually a bad idea? It's a little complicated. Good question. And it's a little bit individual how people will feel. When you're talking about the electric fields from electricity-related things, those ELF electric fields, then this the earthing yourself is a real problem in that environment. But when you get into the radio frequencies, it's a little more mixed. So when you get into the higher end of the radio frequency spectrum, into the gigahertz range of frequencies like 2.4 gigahertz of Wi-Fi routers, the 900 megahertz or 1900 megahertz of cell phones and cell towers, that's a fairly high end of the radio frequency spectrum. And those, it doesn't make that much difference whether you're grounded or not. But when you go into the lower end of that spectrum of radio frequencies, like the AM radio stations, ham radio, it starts to make more of a difference whether you're grounded or not in attracting more of the fields. So just to be safe, I always like to have the radio frequencies very low where somebody is earthing. And one of the reasons that I would say, hey, you want to have your radio frequencies less than 0.001 microwatts per centimeter squared where somebody is earthing is not so much because of that antenna effect, but if you're trying to do earthing to feel well, you shouldn't be in a radio frequency field to try to feel well, So to me, if it's not just the interaction that because you're grounded in earthing, it's that if you're trying to be well, it's too high of a field no matter what you're doing. Thank you so much for those questions. That was from Marianne. And let's see, I think I had something here from Tony. Yes, so this is a good one. Hi, Tony. I don't know if you can hear me.
I can.
Oh, great. Thanks. Do green wave filters have the same issue as Stetzer filters in terms of the magnetic pollution issue? Okay, yes. So the green wave filters and the Stetzer filters are essentially the same thing. I know Stetzer would say, oh, no, but they're basically electronically, they're capacitors. They're like big collectors of electrons. So it's the same idea, slightly different designs, but basically they work the same way. And so what they do is in the process of absorbing extra electrons or giving back extra electrons to the circuit. See, the way they keep the voltage smoother is by giving and taking electrons so that the voltage can be smoother. Like if the voltage all of a sudden spikes kind of high, these capacitors will take some of the electrons away so the voltage can stay steadier on your wiring. So it's this give and take. And when you give electrons or take electrons back, you are initiating a current, and currents make magnetic fields. So that's the downside of all of these capacitor type filters, which includes the green waves and includes the Stetzers, is that you make magnetic fields as a result. So it's pretty much the same thing, same magnetic pollution issue with each one. And do people who react badly to Stetzer filters do okay with green wave filters? So I've never seen that. To me, it's the same thing. If they're having trouble with Stetzer filters, you wouldn't say try green waves. It would be the same thing as far as any way that I could understand it. Very good. Do you have anything to add to that, Tony?
Well, in talking with the green wave people, they make 3 different models of
yes.
capacitors. Ones they've got, and I talked to them at some length, and apparently the one that they have, I've forgotten the model number of it, that it's the oldest one that they have, and they've got a customer in Ireland, I think, who buys hundreds of them and who can't use Stetzer filters. So, you know, for some people, there is a difference. I mean, they've got one, too, that instead of using 1 capacitor, it uses 3 capacitors. So, you know, I'm not sure how this all works, but, you know, I'm curious about it. So I've been experimenting with some of my clients and saying, look, you can't stand Stetzer filters. Try these and see if they're any different.
Yeah. My guess is, I have heard that particular thing that you just talked about, where some of their clients having that better experience with those. My guess is that it has to do with that the older style actually doesn't have as much capacitance in it, so it's not doing as much of a negative magnetic field effect. But just my guess. And it's hard to say these things, but basically, as far as function, I don't see why there'd be any difference between them. The big difference being how much capacitance is there. Like originally, the Stetzers did a certain amount, had a certain size capacitor. The green waves were a little bigger, so when you do your measurements of the dirty electricity, the green wave filters did a little better in reducing it, but that's because it was a little bigger filter. And if you took 2 Stetzers, then you have like a double size there. So all of those things affect the dirty electricity and the amount of magnetic fields. And what happens also is, and it gets really hard for people to tell, but dirty electricity is always changing. And you can kind of tune the filters the right kind of amounts and places for one situation, and then the next day it's different and it's not the same thing. And sometimes people think there's a difference between filters, but sometimes it's actually that their wiring dirty electricity has changed. And it might not be as bad the next day, and that's when they tried a different one. There's a lot of possibilities there.
So it still benefits the most to have low skin voltage readings and not worry so much about the dirty electricity.
Yes. That's another one of the reasons why I shy away a bit from going into dirty electricity filtering, because there's downsides and because the dirty electricity itself is kind of a moving target.
Right.
Very hard to deal with. In some cases, it's relatively stable, but I've seen quite a lot of changes.
Right.
So given it's sort of technologically difficult to do much about it, and it has downsides, that's why I work on getting the body voltages down. So you're actually decreasing the delivery. You might still have it on the wiring, but it's not getting out. So basically, I look at it as the lower the body voltage measurement, the less that dirty electricity in the wiring system is getting from the wires in the wall out to you.
Right, exactly.
Great. Yeah. Thanks so much, Tony.
Sure. I have another question if you're in for it.
Yeah, go ahead.
Okay. There's a new Carnet meter that does all three things: electric meter, gas meter, and RF meter. It seems like it's pretty interesting. You know, the man Josh Dusol. Well, he's selling those meters and making a lot of noise about how wonderful they are. Have you tested out that meter?
I haven't tested it. He's always liked the Cornet meters.
Oh, he has?
Oh, yeah. So when he first came out with the movie Take Back Your Power, that's the Josh you're talking about, correct?
Yeah.
Yeah. He was definitely plugging those. So they're good as far as low cost, but they're really almost like too low end, in my opinion, for us to get much value out.
Well, that's what I thought too. And then, you know, I was impressed with this movie, and he's, you know, really pushing this thing. And I thought, well, I wonder. I'm going to ask Michael. So here I am asking you.
Yeah, I think they're great meters rather than nothing.
Right.
I'm not sure about the new version, but the old versions, basically, they've almost been more trouble to the clients I've known than help. A few people have like really loved them when they really know how to use them, but people get even confused if they're measuring magnetic or radio frequency. They don't see the settings properly.
Right.
It's single axis magnetic, and they undermeasure the magnetic. I've seen all kinds of issues that are just, to me, it's just too low end of a meter unless you are fairly skilled, like someone like me, myself, some of us on the call here. We would know how to use it, but the average person ends up getting kind of really kind of garbage information a lot of times.
Right. I understand. I just thought I'd run it by you.
Yeah, thanks.
Sure.
Pretty much from what I've seen, the closest thing that I've seen that comes to maybe a half decent combination meter, all three things, is maybe the new Tri-Field, the TF2.
Right.
We've done a lot of testing on its magnetic accuracy, and that looks pretty good. Any of these meters with the handheld electric field test, I don't find that useful. I want to do body voltage.
Right.
And the radio frequency for the Tri-Field, I haven't tested it enough to say. What I've done so far, I haven't been very crazy about its radio frequency function, but I haven't done enough to give a. We have one here to test, but I haven't put it through enough tests yet to give an opinion.
Okay.
Thank you, Tony.
Sure. Thank you, Michael.
See, we have.
Is there any way to make your voice louder? I can barely hear you. I've got everything at this end tuned way up.
Oh, that's too bad. Yeah, Satya, something's going on.
That's better right now.
Okay, I just moved it closer again. I'll try to speak louder.
Yeah, that's helping.
Yeah, thank you for letting me know. I actually have 4 new microphones here just to see what'll work better in the system, and everything wired, of course.
Right.
But, thanks.
Sure.
So, let's see. Some questions from Ishana, and let's see. Hi, Ishana. I think you're on the call. Feel free to chime in if you want. And I think I saw.
Hi, Michael.
Hi there. And I think I saw that Najla had been on that. Wasn't maybe? Yeah, I think if you're there, Najla, just letting you know. If I had known you were going to join us then, I would have waited. But we'd actually went through your questions a little earlier, so that'll be on the replay. And let's see, Ishana. What should I start with here?
Ishana or I'm sorry, Michael. The questions that you went to earlier in the call, I was also late to the call. Whose questions?
I'm sorry. Who is this?
Ishana in Vermont.
Oh, hi, Ishana. Yeah, I was just going to go through some of your questions.
She's really soft. I can hardly hear her at all.
Yeah.
Well, I'm in my. I have my headset on.
Very good. Well, we'll have to work with that. And I have the questions here. So it's time to talk certification. That's great. As you probably all know, you can get a certificate for completing the e-course. That's a basic certificate. And, we're in the process right now of kind of figuring out what to do. And I'd actually love everybody's feedback, not during this time, but if you want to email me back. kind of looking at an entry-level certification for people who have gone through the course. Maybe a little more going through, making sure kind of one-on-one that, the material makes sense to you. And then kind of going over the minimum meters of, so I can see doing some kind of initial certification. In the long run, what we're working on is having a much more complete training. Like some of the questions here are already sort of approaching more detailed training. And my plan is to have a much more in-depth full training course than just this beginning training course with a lot more details in it. So please give me your feedback on what you would like also, because that could be very helpful for our planning. And what special considerations should I make when testing a school? When I test schools, I usually kind of ignore the electric fields. There's so many complications, things going on already, that I pretty much focus on the magnetic fields and the radio frequency fields. And for some schools, even we'll just focus on the radio frequency because we're concerned about that and even not do the magnetic. So first is, what do you focus on? And you don't want to make it too crazy. Special considerations. Often when I'm doing a school, I'm looking at where the kids are sitting, and I'll often look for like the worst, like where's the strongest radio frequency spot. So rather than try to test the whole room, so I say, rather than just give one measurement in the center of the classroom, or try to write down 20 measurements all over the classroom, sometimes I'll go around and I'll find the strongest place in the classroom, and I'll record that. And I might say, towards the back of the classroom or in the center or the front. So let's see. Do you have any more on that, Ishana?
Oh, yes. So I've been asked, it hasn't been confirmed yet, but a parent has asked a headmaster if I could come in and test their elementary school. The parent's also on the board of school board. So
yes.
And they know that I'm new at this, and I did find some literature online about guidelines for wireless safety schools, and so that had some guidelines for school staff, minimize exposure, but it didn't have anything to test. And I feel like schools would have maybe different breaker systems. Sure. Or so I know routers are scaling. And if Ethernet is not a possibility, how do you advise schools handle kind of exposure? But also, where the power supplies are they more industrial grade?
Yes, so I see. So one thing is the testing protocol. When you're doing a school, how do you go about this, and what do you want to test and where? And then another thing is, how do you say what the numbers mean? And one of my recommendations with schools might be to just use the information about what's the lowest level linked cancer, both for magnetic fields and for radio frequency fields. That 0.2 microwatts per centimeter squared for radio frequency fields. For magnetic fields, 1.0 milligauss. Since that's the lowest that's been linked to any of the studies, that's kind of a more doable number that maybe a school can kind of work with. And then what you do about it, that's where it gets, complicated. Obviously, you can try turning off sources to see what it is. But a lot of times you can't do that. You can't mess around with breakers for turning off circuits, or even turning off the Wi-Fi and things. What we do sometimes is, what I've done, I'm thinking of a case where we did, there's like a Wi-Fi hotspot in the classroom, and I could access it, and it was it's powered by an Ethernet cable, so there's an Ethernet signal coming into it, and it's power over the Ethernet also. So just for a moment, we unplugged the Ethernet cable from that hotspot and then could measure and see the difference, what that was doing. So sometimes you can do sort of safe little things like just pull out a cord temporarily. But if you get into any more than that, you pretty much have to work with someone. It's often not even the regular maintenance people; it's even the special people who are doing the internet technology for the school. You have to have one of those people and say, "Hey, can we turn this off?" The biggest thing that I've been involved in with this is where most schools that I've worked with will not get rid of the Wi-Fi, but they will relocate it. And we've worked to, instead of having it like right above the kid's head, put it farther away, like in the storeroom next door or some other place where there's still enough, strength of signal, but it's not right on top of the kids. So there are kind of different ways that might go in a situation. That's part of the creative part of doing this work is how do we reduce this? And every situation is a little unique.
I've got a question, Michael.
Yeah.
When I do this, it seems really important to me that all the kids have their cell phones off.
Good point. Right. Oh, I'm assuming usually I would do this. The kids wouldn't be there.
Yeah. Well.
This would be after hours. Yeah.
Yes. But
okay.
Yes, because otherwise you're right. You can measure with the kids there, but then it's just more complicated. What you do is you get an accurate test of what's really happening in the classroom as a result of all of those sources, including the kids' cell phones.
Yeah, it seems to me that both of those things are important. All the kids gone, yes, but all the kids there, yes.
Yeah. Yep. So those are two different testing protocols you could consider.
Interesting demonstration.
Yes. Very good. How to ground Ethernet. Ground at the router, switch, or cable. My Ethernet cable by bed adds 0.6 volts. That might be getting a little too much for our introductory course, but basically you can, when you get this body voltage, you can get from a lot of things. You can get it from, of course, from electrical wiring, regular electrical wiring. Sometimes you can get it on the cable company cable, on the phone company cable, on the Ethernet cables. I've solved several problems with the body volt by actually grounding the router or the device, because sometimes there's just a two-prong plug for something that the Ethernet cable's plugged into is ungrounded, and I'll ground that device, and I've solved some of those problems. But it gets a little complicated. You can do a shielded Ethernet cord, and then there's several ways to ground that. So there's different choices. It's a little complicated, but if you do get 0.6 volts, say, from an Ethernet cable, that wouldn't be normal. There's something going on, and that is a detective job and not necessarily an easy one. Is it advised to ground metal furniture to wall outlet rather than earth? For metal furniture, if you can ground to the earth, that's better because that is a much cleaner ground. If you ground to the wall outlet, it's probably not so bad, but it depends on your building how bad that is. The dirtiness on the grounding system. This is a different kind of dirtiness than the dirty electricity measurement, which is the voltage on the wires. This is the ground wire. The Stetzer meters, green wave meters, they don't measure that. We have a procedure we use to use basically the body voltmeter to test what's the voltage on the grounding system of the building. Just like you test the voltage on you, we test the voltage in the grounding system. So it's a little bit more advanced, but often, in other words, if you have very low voltages on the grounding system, then maybe grounding the metal furniture to the electrical system ground is okay, but the worse that your quality of your grounding system is, the more voltages on it, then the worse it is to ground something to the furniture to that grounding system. And it depends. And also depends, for me, it's a big choice of who I'm working with. If we're just being proactive, protecting somebody, they're not EMF sensitive or sick, then using the grounding of the electrical system for, say, grounding metal furniture usually isn't so bad because we're usually doing something else that's helpful. But if it's a highly sensitive person, the more sensitive they are, the more I will say don't ground to the electrical system, and you have to do an earth ground. Is it a good strategy to scrape some paint off the metal furniture or elliptical machine and use electrical tape to secure a grounding wire to the bare metal? I am thinking the paint powder coat is non-conductive, and grounding the metal would bring a client's elliptical down from 22,000 volts to a safe levels. Yes, it is. There's a little bit, but there's actually a continuity test. It's where you take a standard electrician's voltmeter and you test the continuity of the material, and sometimes it'll look like it's metal, but it's actually a coating that is not conductive. And so, yes, in a lot of cases, like I do this on lamps sometimes, where I want to like ground this long spindle of a floor lamp, and I'll file off some of the paint to get down to true metal, and then I make my connection for grounding there. The problem with taping anything is that that kind of connection may not be robust enough. Sometimes things with tape don't really secure it well enough over the long run. So I'd be looking for some way to clamp it, screw it down, something where it's much more held there, like even like a clamp, depending what we're, if like in some cases you can actually get an electrical ground clamp, a pipe for clamping onto water pipes at a hardware store, and that basically clamps to pretty much anything around. You can get different sizes. You can get, to go from like clamping on something a 1/2 inch diameter up to like 2 inches diameter. And so sometimes you actually get a specific ground clamp for that. What does it mean when body voltage jumps even when sitting still? For example, from 0.03 volts to 0.3 and back and forth. Okay. Usually, if you're really sitting still and you're getting some voltage jump, usually there's something changing in the environment. What I find is often people are still moving a little bit, and it's amazing. Sometimes just a little bit of movement, you get a higher number. And also, when you're in this lower range, like you're only like the 0.3 and down, 0.3 volts down to even like 0.03 volts, you're getting into where even the meter is a little fluctuating. Like some of the meters are not really accurate at 0.03. If you're getting fluctuations like from 0.03 to 0.06 to 0.1, that's a pretty normal fluctuation. 0.03 to 0.3 is a little more than I'd usually see, and I would expect that that's not a normal fluctuation of the meter or even moving around. It sounds like something in the environment has still got a little bit fluctuating. Probably it's in the environment. My house ground wire is attached to the water service in the basement. It reads 0.046 amps inside and 0.02 amps outside on the clamp-on ammeter. Okay. Should it be exactly 0? Should they match, or is there a margin that is okay? So, Ishana, are you still there? Yes. I was going to say, I was basically going to ask what clamp-on ammeter you have or how much you paid for it to kind of give an idea of like what end of the quality range. Okay, maybe lost you on the connection here. So 0.04, 0.02, most clamp-on ammeters, they're your sort. Oh, I say 0.4, no, 0.046, 0.02 amps. That's a relatively low level of amps, and most of the clamp-on ammeters that are under $100, $200, they actually are not very accurate when you get down to that 0.0 something. 0.1 they're doing pretty good. When we're getting to like down 0.02, 0.04, 0.06, you're kind of at the bottom of their ability, and they're probably not reading accurately anymore. So those numbers are so close that I would guess that is just the inaccuracy of the clamp meter if it's the typical kind of clamp-on ammeter. you're under 0.1 amps. If we knew this was an accurate measurement, then we start to look at why do we have 0.046 in one location and 0.02 at another, and usually there's an explanation that there's another 0.026 going somewhere else, and you can trace that around. But at these very low numbers, it's very likely the meter. My house is 0.340 volts on the body meter with the main breakers shut off. Seems high. Yes, I agree. That's high. 0.34 volts on the skin with the main breakers turned off. Not sure what the cause could be and how to get down to 0.1 volts. Grounding to earth would bring the 0.340 through my body. Yes, grounding to earth. I think Ashani means is like if you're earthing. Earth. So yeah, probably we should talking about earthing. That's right. If you're earthing, that 0.34, you're attracting to you. It's not a high number. It's not like 3.4 volts. It's only 0.34 volts, but it's still significant. As a sensitive person, I recommend not earthing in that. Let's see. Yeah, 0.34 is higher. So here's what's typically going on. In some cases, it means that there's a power line close by. And you're getting a little bit from the power lines. And I have seen houses where the power lines are close and there's a lot of metal in the house. One house I'm thinking of locally here that had a kind of a metal insulation kind of blown in the attic. It was not grounded, and that, just like your body picks up voltages, that metal insulation was picking up voltages from the power line in front, spreading it to the whole house. We ended up actually grounding that metal insulation, and that went away. Another very common thing that happens is when you go back to your electrical grounding system, and this seems to be getting worse. I seem to see this more and more now than I used to 20 years ago. The grounding system itself, which is theoretically supposed to be 0 volts, is usually not really 0. A lot of times it's 0.1 volts, about a tenth, but a pretty normal range around the Bay Area is 0.1 to 0.3 volts. And often when you start getting around 0.2 or 0.3 volts on the grounding system, this is compared to a rod in the earth, you would think they'd both be 0, the same voltage, but actually the electrical system ground is dirty, has some voltage. And so that this 0.3 volts on the body actually sometimes is the kind of thing that's actually the little bit of electric field that's emitted by the grounding system. It's a low level, but it's there. So I find, like, let's say you have, let's say that your grounding system for your building only goes down to 0.2 volts. Well, then it turns out your body voltage measurements, typically you'll only be able to get down to around 0.2 volts, because all this grounded metal around you for the wires, even any shielding material, they're all at that 0.2. So your body voltage doesn't go any lower because they're picking up that little bit from the grounding system. And it's really unfortunate. And I do have a client in Canada who was considering going off the grid because they had in the range of 3 volts on the, not 0.3, but 3 on their grounding system from the utility, and the only way they could get rid of that would be to disconnect from the utility and go solar and have their own grounding system independent from the utility's grounding system. So I have a suspicion that in this case, this 0.340 might be on the grounding system. And one of the things that you can do to check that is, well, actually it's a little, probably that we'd have to, I better not give a quick direction that, because it is a little, we want to make sure that you don't do anything where you harm yourself but basically there's a way to use the body voltage meter, and instead of testing on your skin, you test on the grounding system, which can be sometimes like grounded pipes, or even go out to the electrical panels where you've got the metal, touch the metal to it, see what the voltage is, just like you check your voltage on your skin. In this case, you don't touch the probe with your skin, you touch the probe to the metal, like the metal of the panel, and that's a pretty good idea of what's going on with the grounding system. And there's more complex things we can do. That's actually should be a whole class in itself about how to test grounding. that's a much more advanced kind of issue, probably beyond our course right now, but a very important one. So I'm really glad you brought that up. And let's see, body voltage meter assembly. Made my own using the do-it-yourself instructions. I've not been able to find instructions for assembling a skin probe other than using a standard banana plug cord with the standard probe end. Don't want to use this though because I don't want anyone to get shocked. Maybe, Ishana, if you're still there, if you're doing a body voltage measurement where you have one end of the body voltmeter, that wire that goes to the earth, and the other end you're holding, there's no way to get shocked there, so maybe I don't quite understand, or I'm missing something. But yeah, you should be able to hold the probe and not get shocked. There's, are you there, Ishana? Did you want to explain that? Not picking you up. So maybe, but yeah, normally you would not get any kind of shock by holding the body voltmeter. Now the exception is I've had very, very sensitive clients, and they don't want to hold on to it. They feel stumped, even though there's very little coming from that body, but the meter itself, that little electrician's voltmeter, and it's grounded on one end. But some people they're so sensitive to so many things, and in those kind of cases, I don't test on them. I do it on myself, and basically the body voltage test, it doesn't really matter who you're testing it on. A similar sized body, one person to another, gets very similar measurements. You know, children are smaller, so they have a lower measurement. A bigger person, more surface area, bigger measurement. But generally, an adult, you get a very similar measurement. And then regarding magnetic fields, shielding a source other than wires. If the source is an electrical unit of some kind, or some kind of electrical device, I think what you're saying, rather than the wiring, can that device be encased in mu metal? Yesterday I got a reading of 200 milligauss, I'm assuming, and climbing directly at the unit. Yes. A TACO valve for radiant floor heating. Yes, I've got those myself. The wiring for the unit is BX and had a low magnetic field. The field radiates up into the kitchen so that standing at the sink, the floor is at 4 milligauss and the stove floor is at 2.5. I'm using the LPUHS2. That's great, totally. And yes, you can. In fact, the easiest thing to shield for magnetic fields are small sources, small compact sources like that little actuator for the heating unit, that TACO valve. So what I've done is I've made like a little, you know, like boxes would have 6 sides, but I make a 5-sided box that just slips over the thing with mu metal, tape it up, maybe 2 layers of like a 4 mil mu metal, and I make like a little cube with the bottom open and just place it over the device. Something like that, and you'll usually get quite a good reduction. And I've done that several times for this very purpose, for this very kind of valve. So, you know, if we were planning this house to begin with, we would say, do not locate your hydronic water system and its valves and motors under the kitchen or under a bedroom. We try to do it in a different place. One job right now we're putting it under kind of a hallway and closet. And we're telling the electricians and the plumbers, don't plumb it up high, bring it down as low as they can on the wall in the basement where they're doing this so that you have more distance. Very good question. Thank you.
Thank you. Michael, can you hear me now?
Yeah, I can hear you now. Yes.
Great. I switched over to phone. Sorry about that.
Oh, yeah. Yeah, it's kind of...
I heard all your answers. Thank you so much.
Oh, great. And when you were talking about the body voltage meter and getting a shock, you were just talking about the standard. Maybe did I understand that correctly?
Yes. So the little probe that comes with it, the pointy probe that comes with it,
yes,
with the multimeter. One of my clients, I haven't had this with anybody else, just one. She kept feeling a little shock, and it would make her, not jump as in but it's just a little jump, and each time, and she didn't like it very much, and so I ended up, being the body, But it made me curious, and not, I didn't want to be harming anyone, you know.
If somebody says they feel anything, I just take it out. I don't think there's no measurable shock, but that doesn't mean someone is not having some kind of sensation. I assume it's a highly sensitive person you're working with there.
I think yes, I agree. And I think because of this testing, she has had a paradigm change around that. And she's starting to see that a lot of her symptoms or suffering could be related to EMF exposure. So I don't think she realized just how sensitive she was. She just knew something was up.
Yes. If somebody is having a reaction to the body volt test, they're probably having 100 other reactions. That's a minor one. Yeah, she has quite a few things going on. So yeah that's interesting. Mm-hmm. And then the moon metal, the moon metal encasing. So I heard that you have the same unit that she does. Probably I have Takeo valves. I put in my own hydronic system. So I actually kind of designed my own. Yeah, it's a very common thing to have these valves that actuate, and they make a field, and they're usually often done below, and sometimes it just happens to be below a kitchen or bedroom.
Exactly.
Right. Right. That's so in play now. If you're ever helping people plan things, and you think of all those funny little electrical things to keep them away from places like that.
Yeah, that's great. Well, I'll definitely let her know that encasing it is a good idea, and the way you said, or relocating it.
That's right.
The unit.
It's usually that's kind of a big plumber's cost. So typically you can do quite good by doing a little shielding.
Okay.
And for shielding this, it's nice to use a mu metal. You can use Gyron also. G-iron. They're both good for shielding magnetic. The mu metal is easier to cut and form into what you want when you want a small thing like that.
Yeah.
And for anyone who's going to look for materials, one of the things that happened last year is there were some materials out there that were misrepresented or was confusing. There's different. So with G-iron, it's all the same. It's G-iron. But with mu metals, you can tell there's actually different levels of heat treating. And there's something called fully annealed, but annealed just means it's kind of ready to be worked, and it's not fully heat treated. And so basically, you can have a mu metal that looks the same, and after it's heat treated, it's 3 times more effective than when it's not heat treated.
Oh.
And some people don't know that, and they sell the material. And so I've had trouble with suppliers myself. So if you're usually for small amounts, you'd go to something like Less EMF, and you want to say, hey, I really want to make sure this is the material that is fully heat treated for maximum magnetic permeability.
For maximum magnetic permeability.
Yeah. Fully heat treated for maximum magnetic permeability. And it's hard, and you just have to trust, last year I had to just buy I basically had to get a lot of my own and send it through, get it treated myself. But for the good mu metals, half of the cost is that heat treating. So you can imagine someone who wouldn't mind passing off the sort of cheaper stuff without knowing. And you can't tell. Yeah. I can tell by testing it, but I can't tell by looking at it. It's nothing you can see. The heat treating is actually a process where they put it through an oven and in a strong magnetic field, and they align all the molecules kind of like in a magnet so that you get these magnetic properties. It's also why if you heat mu metal too much, you could take a torch to it, you'll randomize the molecules and you'll lose its magnetic effect. Not a concern for us, but just to let you know, I've been burned by getting the wrong materials, and I'm very aware of this stuff. So make sure you ask for fully heat treated for maximum magnetic permeability, not the cheap stuff.
Great. I wrote that down in quotes.
Anybody else online, especially anybody who hasn't asked anything yet? Did anyone before? I have a few more questions written here, but I want to make sure we're getting the people online right now. Okay. I'm going to go on to Christine. Saw some questions here. Let's see. These are all good. Yeah. What do you think about the Power Perfect box? I'm hearing very good things about it. So a lot of you have maybe heard of the Power Perfect box. This is a type of filter for dirty electricity. And the Power Perfect box, it's made by the SATIC, S-A-T-I-C. I think it's SATIC.com. I'm not sure what the website is. I have some of their filters. I do not now yet have the Power Perfect box. I'm going to get one. I'm going to test it on a job soon and see how I like it. The Power Perfect box is a whole house type of box, not the kind of thing you plug into an outlet. It's the kind of thing an electrician installs at a main electrical panel. And this one looks promising. I've looked into it. There's some positive and negatives. One of the positives, it's only in the $1,000, $1,200 range. An even better product is the DNA filters, but for the whole house version, you're usually talking in the $5,000 to $10,000 range. So the SATIC looks like pretty good for its price. My guess is that it'll be great for some situations, but that there'll be others where the SATIC will not have enough capacitance. And what I have done in the past is I often install multiple green wave filters or multiple Stetzer filters at some outlets we make right there. We put in right at the main electrical panel. And sometimes there's things like solar panels and inverters on the house. I've had to go up to 4 Stetzers on each phase. That's a total of 8 dirty electricity filters. And what I suspect with the SATIC is that in some of these cases, it's going to be overwhelmed by the strength of the dirty electricity issue. But what's good about the SATIC, this Power Perfect box, as it's called, it's a more sophisticated filter. It's doing more things. It's not just a capacitor, so it's doing other things as well. But I am concerned about their claims. I do have a client that said, well, they say it reduces the EMFs and all this, and 90% of the EMFs or something. So when I look at the literature, I don't think they necessarily even understand exactly what EMFs are. When somebody says, well, it reduces the EMFs 20%, there's all these different kinds of EMFs, and they're not saying what they're talking about. So as we all know, you have to be more specific. Are they talking about magnetic fields, electric fields, the dirty electricity, the radio frequency leakage? There's all kinds of things that are in the generally called EMFs, and they made some claims that to me were not precise enough to really know what they're talking about, and that concerns me that what their claims are saying. But I'm going to be testing one myself, and maybe by the next, at least definitely in 2, but probably by the next Q&A, I'll have some information on that. And then there's a smart meter guards that claim to shield the RF from coming inside the house as well. The smart meter guards, some of the companies, the claims are kind of crazy. Sometimes they claim like stops all the RF from getting out to you, but keeps all the RF getting out to the utility, and there's sort of like no way to do both. So what most of the guards do is they do a fairly good job of reducing what comes out of the smart meter, in the range of 95 to 90%, 99%, quite a good factor of 100 maybe. And in that case, a lot of times the utility system still works because even at 100 times less strength, that still might be 1,000 times more than needed to work in the system. So it works for the utility, but you've reduced your exposure maybe by a factor of 100. So there's always some leakage, and I have not seen any kind of smart meter guard that reduces directly the input to you. What happens with most electrical panels is you have some shielding already, because behind the meter that the electrical utility puts in there, that smart meter, there's a metal panel. And depending how big that panel is and around, that's actually already a shield. There's a lot of reflecting. A lot of that smart meter signal goes to that metal box behind it, and it goes back out away from the house. So when you're putting a guard on there, you're not changing what's behind there, but you are changing what comes out the sides. And actually what happens in a lot of cases is you get a lot of your smart meter signal from your own smart meter, partly from what still gets kind of goes backwards and gets through the metal and around. But a lot of what you get also is what comes out the front and especially the sides, that going out the top, bottom, and reflects off of other things like the neighbor's house 20 feet away or the fence or a tree, and bounces back into your house. So, especially through windows. So a lot of the entry of your own smart meter comes from reflections that first head out from the house but then get bounced back. So when you do a guard on the smart meter, you're reducing that amount of radio frequency that bounces back to you, because not as much is coming out the sides, the top, and the bottom. So in that way, the guards can help reduce your exposure to what you're getting inside, definitely. But I know of none that directly does that. Let's see. And of course, if you can opt out of the smart meter, that's the best. I've seen another EMF professional recommend testing body current with the Fluke meter, which she said costs $1,000. She says that sensitive people are often reacting to this when the body voltage is low. It's still not clear to me why the combination of a sensitive milligauss meter and a body voltage meter wouldn't do the trick. So I'm checking to see what you think. Probably here, Christine, I might need a little more information. So there's so when you do a body voltage test, you're testing the voltage on the skin. And there actually are ways that you can sometimes even measure little currents on the skin or currents in the body, way beyond what we can do. We're talking, more like high technology and scientific labs, kind of like doing, EEGs and EKGs, where you're measuring stuff in the body. Those are mostly voltages also, but there are ways to measure currents in the body. What I'm thinking what's going on here is when somebody is earthing and you connect yourself to the electrical ground, or you connect yourself to the earth itself with a ground rod, your body voltage goes way down because now you're at the voltage of the earth. But the reason that your body voltage goes down, it has to do with electrons flowing again. Just like the dirty electricity filters, those capacitors give and take electrons. Well, the earth is doing the same thing to you. You can't build up a voltage because the earth will take or give electrons to keep you at this low voltage. So there's actually a little current that runs to do this. So if you're in let's say that the body voltage in a room is, let's make it really high, 5 volts on the skin. And then when you ground and earth yourself, whoa, that voltage goes down to 0, say in an ideal situation, 0.0 volts. But that field is still there. The field is not gone. The field is collapsing on you. And what's happening, it's draining away via a current, which means now there's a little current. And I'm assuming what this other tester is doing is they're measuring the current on that ground wire between the person's body and the earth. And that is, so if you have a 5-volt body voltage, you're going to have a fairly strong current running across your skin and through this ground wire. If you were in a 0 voltage body voltage field, then when you grounded yourself to the earth, you would not get any current on the ground wire or on your skin. So, like for instance, I never know when people are being affected by electric fields, would they be better off having having a low voltage on your skin, or would they be better off grounding that and having a current on their skin? And I found them both bad. So we don't usually even give that as a choice, but some people actually work with that. Oh yeah, I'm okay with the current. I don't want the voltage, or or vice versa. But basically, you can do a test if you have a sensitive enough test meter to test the amount of current that flows through that ground wire that's basically on your skin to the ground wire to the earth. And I assume that that's what this other professional tester is doing. And I have meant to do that myself. I have not done that, but you do need a fairly sensitive meter to measure those low amps. The typical $100 voltmeter is not going to do it. You probably do need to get into the $1,000 range to get something sensitive enough for that test. And I would agree that if somebody's earthing and you measure a current, that is an indication that they're actually acting as an antenna. Their body voltage is low, but their current goes up. If you think of it, if you're earthing, if you had a high voltage before you earthed and then it goes down after you earth yourself, that's going somewhere, and it's going through that ground wire, and that current is testing that. So yes, Christine, I think that is a really good test, and it could take $1,000 meter to do a good enough, a sensitive enough test of the current, because these are not big currents. This is not like the 2 amps that's running through your wires. This is about this is a very low amount on your skin. Let's see. I think did I miss one here? Oh, here's some questions on grounding lamps. I have something here. I actually got a little material together for us. If you're wanting to, let's talk about shielded cords. And I'm glad, thank you, Christine, for sharing this, because I hadn't seen this before. Amazon now even carries shielded cords. I used to have to go to a company online called Mouser.com. Find it here. This company, Mouser.com. And here's some information about getting shielded cords. This happens to be what I found at Mouser. I updated this just a couple months ago. Things keep on changing, but you're basically looking for a shielded cord of different sizes. These are wire gauges. And for something like a lamp, we're usually looking at an 18 gauge cord. And the numbers can be confusing. 18 is smaller than 16, and 16 is smaller than 14. It's kind of backwards. This is a big one. If I was making an extension cord to do something like with a heater on the end of it, I definitely want a bigger size like this 14 gauge. If you're just doing a lamp, use a smaller size like the 18 gauge. And so there are the shielded cords available. What you can find right now, the shielded cords are always this type. You have the American end on this end that we're all familiar with. And on this side, you have the C13 IEC type of cord end. And you might recognize this. This is a similar shape that you sometimes see on the back of a monitor or a printer. So if you have one of those devices that uses this kind of outlet, let's see, do I have a drawing here? It'll look like, oh, I guess I don't. Oh yeah, like sometimes you look at the back of a printer or a monitor or a computer, and you see this arrangement here that plugs in, special plug-in. That's that IEC end kind of cord. You can throw away the one that came with the machine and get one of those shielded cords on Amazon for like $6. Again, something like this. This is a picture that Christine sent. You can see this here. This, I think, was actually an air purifier. Here's an unshielded cord. She could just get a shielded cord, plug it in there, and you've just solved the problem of all the electric fields from the cord. Because you may know, as you may know, around a lot of things at a desk, a computer desk, sometimes the worst electric fields are the various cords for things. And I found, sometimes I found like almost all the cords can be replaced, or half of them can be replaced with a simple cord like this. So the first step is sometimes you can simply get one of these shielded cords here. So basically you get something like this, the American end on this. You have this IEC C13 is what it's called on this end. You can just get cords like that. This one is 4 1/4 from 12 foot long from Amazon. So that's getting very available. That's great. Back here. So you can get a cord. Here's Amazon. Here's another one like $7. Very, very cheap. You can get a couple of those. If you wanted to extend this, it's nice. I just found this recently. You can get an extension cord where you have the C13, C14 ends here, and you can extend that cord, which is really great. You can make a longer length. These are 15 footers. So, and then what you do is at some point you have. Here, I was going to show you Safe Living Technology. It has that. I think that's slt.org. I think that's their website. They have it if you're looking for it. So there's a lot of places that you can find that at now. Less EMF. I was going to warn you, it's confusing. I would advise against getting the Mu cord. This is advertised as being great, but there's some problems. This is a whole lot more expensive, and it's got extra shielding for magnetic fields. But the magnetic fields from the cords are almost never the issue. It's the electric fields. And this is not a UL listed material. So here in the United States, this is not a legal material to use for wiring or for even lamp cords. It's not approved. It's not UL approved. So I would avoid this. And also the way they do it, there's issues with the two wires here and you're putting them together. I would just say, unless you really have an issue with the magnetic fields from the cord, and it's usually the device itself, not the cord for the magnetic fields, I would avoid the Mu cord. Here's the whole thing on, let you know, for shielded cords. And you can go back and you can take a look at this if you want to get this information. So basically you use shielded cords to replace unshielded cords on lamps and appliances, or making your own shielded extension cords. If the shielded cord comes with that C13, that receptacle end, and you're trying to shield a lamp, you just cut that end off. If you're making an extension cord, you also cut that end off and you put an American end on it, and I'll show you one here in a second. It's important to ground the thread if you're shielding and grounding a lamp. It's important to ground the threaded metal spindle inside the lamp fixture also. Almost all lamps, table lamps, floor lamps, there's actually a threaded metal spindle going all the way up, and that needs to be grounded, because then that metal spindle, which the live wires are inside of that becomes a shield also. You have the shielded cord for outside the lamp, but then as the cord goes up and connects into the lamp, you want to ground that spindle. And that's where it gets a little technically challenging, and that's where typically you'd have an electrician do this or bring it into a lamp shop. And I'm going to be making a video at some time to show lamp shops how to do this. Right now I explain to them. You always want to make sure that you get a cord that's a big enough wire size for what you need. If the wire is too small, it can overheat and cause a fire. And again, note that 14 gauge is actually the biggest wire and thus the safest, and 18 gauge is the smallest. For lamps, you're usually going to use an 18 gauge. You don't need the whole, you don't have 11 amps of heater, amps going through it for a heater. So this is usually enough for a lamp. And also, since it's a smaller gauge, it's a narrower cord, and it'll fit better in your lamp. This 14 gauge cord will be kind of too fat. It'll be hard to work with your lamp. And always be careful to wire your lamps and extension cords correctly. If you're doing this, the shielded cords might not have the American color coding. Black is hot, white is neutral, green for ground. In Europe, in some places, brown is the hot, blue is the neutral, and the green and yellow striped is the ground wire. If you're unsure at all what you have, the cord you have in your electrical system, ask an electrician, because you don't want to wire it, backwards and make things worse. Now, so for making a shielded extension cord, unfortunately, I've not found anything yet where you have the American end here and then the American end here. You have this IEC end over here, this here. So basically what you do is you get one of these, and with the IEC end on it, and you cut it off. You cut it right here, cut that off, and you get you put on your own American end. Whoops. You put on your own American end. So there's a little bit of a, very easy to do, but basically you assemble this yourself. So now you have a cord just like this one, but you've got your American end on the other end, and that's how you make an extension cord that's shielded. And again, you can get those on Amazon. Here is this end. I got this one. I found this on Amazon, but you can get it at a hardware store, Home Depot. They don't have to be yellow, often they're black. And it's $5. So you can see, like, you can make yourself a shielded extension cord, like $6 for the cord, $5 for the end here, and maybe for $11 or $12, you actually have a shielded extension cord. Well, here's another example on Amazon. This is actually black. So if you don't want to look at the yellow, and that one's like $10. And that'll always change with time, but if you go on Amazon, these places, you'll find something like this. I think I just typed in, not even sure what I typed in here to find that, shielded cord plug end or something like that, to hunt around a little bit for it. Less EMF, this is from Less EMF. They sell them if you're wondering, hey, I can't find it. Go to Less EMF or call them up. Here's probably the same one that we found at Amazon, this yellow one. They're selling it for $6. So you can get that right there. And again, you can make your own shielded extension cord, or you can get one of those cords with the C14 outlet, C13 end, and put it right into the device. When you're shielding a lamp, always remove the so here's the steps. You're basically removing the unshielded cord, and you're installing a new shielded cord. And how you do that exactly is the trick. Sometimes I do that in the base of the lamp and I make a splice. Sometimes I take it all the way up the spindle and make it at the bulb. That's where the tricky thing gets to be, is where do you make the splice? But basically you're taking off the old cord, putting in a new. And the other thing that I mentioned earlier, it's really important that you ground the metal spindle of the lamp so that the metal in the lamp now acts as a shield also. Let's see if oh, here's another question from Christine about grounding Ethernet cables. That is, again, probably more than we can go over here. Basically, for most purposes, on the sort of entry level of doing work with EMFs, we do not ground or shield Ethernet cables. Think of, generally we're just using regular Ethernet cables because that is so much better than doing wireless Wi-Fi, right? In most cases. And then some, so if you take this, like if you want to get a signal to the computer, one way is you do the Wi-Fi, and that's the worst. You have the radio frequency signal. Another thing you can do is the Ethernet over the power line, EOPL, and that's where you have a device that plugs into an outlet, and it uses the electrical wiring in the walls as your, kind of like your Ethernet cable. It sends a signal to that, and then you plug in something in another room, and you get a cable, Ethernet cable out of that. So you don't have to run Ethernet cables all over the house. The problem with that is it does make more dirty electricity signals on the wiring. You are putting the signal onto the electrical wiring. So that's the downside. But to me, that's still better than having Wi-Fi. And then, of course, the best thing is to have an Ethernet cable all the way. And so that's so much better than having Wi-Fi. For most clients, that's 99% of it. But then with really highly sensitive people, then sometimes, yes, will we shield the Ethernet cable? And the two things I guess that I would say I do is, one is when I run the Ethernet cables, I run them far away from people. Like some clients I've had are so sensitive, we run the Ethernet cable like into the wall of the house, but then we run it like out in the yard 10 feet away from the house and over to the garage where the router is or something. And actually keeping distance, even from the Ethernet cable, is a big deal for sensitive people. And then you can get into grounding it and shielding it, where you get an Ethernet cable, like Cat 6, 7, the Cat 6, something that's shielded. But then you have to like either ground that to the electrical system or ground that shielding to the earth. So there's a little bit of technology in there about how you do that exactly, but it can be done. And but that's probably a little more than we can do in this course. And let's see, anybody else have any questions?
Yes,
Michael, this is Ishana in Vermont.
Yes, hi, Ishana.
Hi. So a couple of questions. One is about sticking with the whole Ethernet theme here. The Faraday cage for the router, I have a question about that.
Mm-hmm.
And then also, I understand that the grounding is too technical to go into on this call, but perhaps it would be simple enough to answer this question.
Yeah.
So, okay, so there's Cat 6, Cat 7, Cat 5. Do some Ethernet cables need to be grounded and others not?
Yeah, this is where it gets a little technical and complicated. So most Ethernet cables are just Ethernet, and there's nothing to ground. It's just the Ethernet cable. And then if you have any kind of shielded Ethernet cable, you get into like, how do I ground that?
Right.
And
if you don't ground it, is that okay?
Well, so actually, we would ground it typically because we're trying to reduce the electric fields that are at a lower frequency, like the ELF and VLF electric fields. But a lot of cables for things like telecommunications are not grounded because all they want to do actually is mostly shield the higher frequencies. So when you have shielding, like you can have a shielded Ethernet cable, and you'll have less radio interference both coming out and going in if it's shielded, whether that's grounded or not. But if you have an electric field, something like that's showing up like a body voltage meter, that's the kind of thing that requires grounding on the shielding.
Okay.
And it's actually similar to something we talked about earlier, where there's a crossover when you're in the higher end of the radio frequency fields, like the 2.4 gigahertz for Wi-Fi routers, or for cell phones, and you're in the 900 megahertz range or the 1900 megahertz range. Those frequencies on that higher end, it doesn't matter so much whether that cable is shielded. Whether that's shielded, the shielding on that cable is grounded. That at those higher frequencies, the grounding doesn't interact as much. But on the other end of the radio frequencies, we're getting into AM radio, ham radio, and some of the more dirty electricity, sort of in the kilohertz even, these lower ends, that starts to make a big difference whether it's grounded or not. So again, we typically ground it because we're trying to do all of the radio frequencies. But if you don't ground it, you do a lot of the radio frequencies. And that's where it gets a little bit into what you're trying to do, how sensitive the person is, what grounding are you using. And so for most people, we don't even get into the shielding for it because it's so much better than wireless.
Right. Yeah, and that's a big step. Yeah.
So I think we want to be careful in a lot of cases to not make it too complicated for people. So with most clients, there's so many things going on. I don't even bring up, hey, we could do a shielded cable and blah 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 blah, because I'm just so glad we're even getting to do an Ethernet cable. This is a huge, it's a huge step, and we're not going to complicate it further. Yeah.
Okay, so if it's not a shielded cable, then the grounding is in. It's okay for it not. There's nothing to ground. Right. Okay, and if it is a shielded cable, then grounding, it becomes an option, but isn't necessarily necessary.
Right. It'll depend on the individual situation.
On the individual sensitivity and situation.
Exactly.
Okay. Boy, I'm glad this is recorded because I'm going to have to listen back to that.
Yeah.
But that makes sense.
Yeah.
Now the Faraday cage. So the Faraday cage over the router. I haven't seen one. I haven't used one yet, but it mystifies me because there are all these like now there's this TV cable coming out of it for some people. There's the telephone thing coming out of it for some people. Yes. How in the world do these cables come out of the Faraday cage?
Yes. Well, so it's not a perfect Faraday cage because there's that opening. So you actually get a certain amount of escape of the field, and it is and depending on how things work out, that cable entrance is a big deal. So you try to do, so some of the boxes for shielding routers are designed in a way that the metals, like the cover and the sides, kind of overlap, and the cable squeezes in between, and you don't have like such a big gap.
Okay.
You know what? Like Satya has done a lot of this. He calls it the router burrito. Maybe you can show you a picture sometime. But he'll take window screen around a router and do like 3 wraps.
Oh wow!
And then bend it over like a burrito. You know, the two ends, and the cord will run through quite a bit of materials, kind of sandwiched in there. The cords that come out of there, and that's the best results we've got because there's so little leakage. But even that has a little bit of leakage. There's no, even a perfect Faraday cage isn't perfect. So, but yeah, whenever you have these cages for routers and things, depending on how big the openings are for the cables, you have a certain amount of leakage.
Right. Okay. And the Faraday cage it seems like that's the option when someone isn't able to turn off the Wi-Fi on their router.
Yes.
But yeah. All right.
I've gone to that more. Sometimes like I think I'm sitting in someone's house and they're already overwhelmed. Oh, I got to call an electrician for this, and and I got to get this and this, and so with some people, it's almost like puts them over sort of the emotional threshold, right? To now have to also call up the phone company or the utility company and try to tell them what you want. And that you want to get equipment that doesn't have wireless in it. And then they don't often understand. They come out with something anyways, or they turn it off, but it's not really off. It gets so complicated that if it's not a highly sensitive person, I think it is a good option to combine 2 things. First of all, even shielded, I don't want that wireless router or gateway like in somebody's bedroom.
Right.
So one thing, I still want to locate that in a place where a little farther away from people, and then I want to shield it. And so for the average person, that's pretty darn good. It'd be better if it was a really highly sensitive person. I wouldn't probably give that option. I'd say, we got to deal with Comcast or the phone company and get you only wired equipment, no wireless. But for a lot of people, this is such a great step. Relocate it a little farther away, the router or the gateway. A lot of times it's the gateway. It's the first box that the cable company or even the dish company or that they have. That's almost always wireless. You just say, hey, let's not change your service. That's a lot of hassle. Let's just wrap it up, put it in a different room, and you've gotten 99% reduction.
And still enough signal.
Oh, so in that case, we're not trying. We're using Ethernet cables, phone lines. We're using cables out of that. We're not using the
that's what I was hoping. Yeah, right. Good.
Yeah.
So getting the distance, wrapping it, and getting that Ethernet cable in there is the least emotionally burdensome strategy.
That's right. And there's more and more systems now where you have no choice.
I'm running into that more and more here. Yes. Yeah.
So I think still with Comcast.
I guess this weekend we were at my mother-in-law's and I was looking at her setup, and her Lifeline is associated with it. You press the button and it calls the emergency services.
Yes.
Yeah. Mm.
Yes, that's right. You start getting into, I didn't even talk to my dad about that. He's 91. God bless him. He's still going. And I'm not going to tell him about his little button and his, but because what can I do? He's going to say, but then how would Yeah. So it's getting more and more difficult to live without wireless for all these things. Like our cars, it's getting really tough now to get the wireless out of cars.
Yes. Yeah, and now do you know of a way that people can get information easily for, most easily for turning off the Bluetooth in their cars? Are people putting together video tutorials or is it just a call to the dealer?
Yeah, basically it's so individual. I mean, there's some where I'm thinking of one was an RV and we just like turned it on and there's the menu and there was like turn off Wi-Fi or turn off Bluetooth, you know. And then other cases, you know, the mechanics can't figure out. We're calling the factory or the wherever, you know, they can't figure it out. It's so individual.
Yeah.
You just have to, the thing that I found that it's really important to do is, and I think it's for buying anything now that has wireless in it and you want to try to turn it off, is that you have to either, like with cars, I tell people, don't sign for it. Say you're buying that car is contingent on they figure out how to turn that Bluetooth off.
Oh.
You know, and then they work for it. Because otherwise, if you buy it and you come back and they'll just say, well, we can't, or, you know. So for cars, you gotta right out front say, you know, it's contingent on being able to turn that off. And don't just tell me you can. I've got my meter here. I want to really see it. And then for other appliances, like let's say you have a refrigerator that's got the Wi-Fi in it now, or whatever appliance, then I would, you know, I would say get something that there's a guarantee that you can return it for any reason. Like when I bought a smart TV a year ago, I got one I thought I could turn off, but I didn't know until I get it home. It was from Best Buy locally where they had like, I don't know if it was a 10-day or 20-day, whatever guarantee for any reason. I got it turned off, so I was okay. But if I couldn't have and no one could figure it out, I could have taken it back and got my money back.
And if that agreement is made up front, then they really can't do. They
That's
can't
right.
do anything about it.
That no, you know, where you have a guarantee, you can bring it back for any reason. And then it's not like you can say, you know, I couldn't turn off the Wi-Fi, and they can't say, oh, sorry, that's not a reason. So I've just found that you almost have to do that these days because it's a little bit difficult to know for sure whether you can really turn off the wireless and things.
Right. You know, along those lines, this, the client who is very sensitive to the probe is a landlady, and in her building where she lives, she has tenants, and they had smart devices all over the place. And they moved out, and she's putting as a condition in her lease for the next tenants that they locate their router, you know, in a certain, nowhere near her bedroom. She has a certain area in their apartment, and she's setting up certain conditions about their use of wireless.
Perfect.
And that they're not allowed to ever allow a smart meter to be installed.
Yes.
Yeah.
Yes. Yep. Very good. I think we're almost out of time here, but just wanted to check, does anybody else have anything we've missed? I think Najla, I think I answered your questions. If I haven't, please give me more detail, and I'll go through that next month. Tom, I know you've chimed in there once or twice. If anybody else has anything, let me know. Otherwise, just give a minute here for anything else to come up. Sounds like we're good. Thank you so much for joining us. Really great questions. This is my pile of paper for questions is almost as big as my whole pile for all the year ahead of this. So critical mass. So I'm glad we got to everything. And I'm sorry, some things do get a little too complicated or kind of beyond like the technology of grounding Ethernet and all the choices there. So some of those things, if any of you do need that, we can do that in a private consultation about the details. And thank you all for joining us. You have a great month. I don't have the date yet for May, but it'll probably be approximately 4 weeks from now. We'll see what day of the week we do that. Thank you so much, everybody. You take care and have a good month.
Good night. Thank you.